everyone. So we're going to start our new unit, Trig Identities, and this is very much related to our units we did, not the last unit, but the one before that. And this first lesson is going to be mostly review and talking about some little new topics. So at the top here, we're talking about reciprocal identities. So this is talking about if you were to flip a function, a trig function, what is it related to? So secant theta is related to cos, so it's 1 over cos. Cosecant is related to sine, cotangent is related to tan. And for tan theta, just a little review. Tan theta is sine over cos. So if cotangent is the flipped version of tan, then it's going to be cos over sine. The Pythagorean identity. So this is going to be an equation you're going to be working with a lot in this unit. It's sine squared theta plus cos squared theta equal to 1. And the next two below it is some equations you'll also use, but it's basically the same equation as the first one, just rearranged. So, example 1. State the non-permissible values for the following. So non-permissible values means your denominator cannot be equal to 0. So here, tan theta, if you were to rewrite this in terms of sine and cos, this is going to be sine theta over cos theta. That means cos theta cannot be equal to 0. Therefore, theta cannot be equal to what numbers? So here, if you were to write your little coordinates, just as a little review, this is 1, 0, 0, 1, negative 1, 0, and 0, negative 1. So cos is related to the x values of coordinates and sine is related to y values of coordinates. So cos theta is equal to 0 at pi over 2 and 3 pi over 2. So I'm going to pause right here. This is where a lot of students tend to make a mistake, is they would give this answer, but this answer is only correct if they gave you a specific domain. So if they gave you the domain 0 is less than or equal to theta is less than or equal to 2 pi, then this would be correct. But in this question, there is no domain given, right? So you have to give a general solution. So your general solution is going to be theta cannot equal to what? So we know pi over 2 is going to be an answer. And for a sentence, it's going to be pi k k ei. A lot of students would write plus 2 pi k because they're used to the other trig unit. But if you think about it, looking at our little coordinates here, the distance between these NPVs is half a revolution, or half a circle. It only takes pi degrees, or pi radians, to get from one to the other. So in order to address both of the NPVs here, for each revolution, is only pi k. If you were to do the full 2 pi k, so in this green here, you go all the way back to this top coordinate, that means you're missing the NPV at the bottom. So that's why you only do the pi k. So the correct answer for this specific question would be the general solution. Now, for cotangent. Cotangent is the reciprocal of tangent, so it's going to be cos theta over sine theta, and that means sine theta cannot be equal to 0 because our denominator cannot be equal to 0. So theta cannot equal to what? So here, where is our y values equal to 0? So our y values is equal to 0 at 0, pi, and 2 pi. But this would be your answer again if you were given the domain. Our general solution here would be theta cannot equal to pi k k ei. Because if you, again, were to go from one NPV to the other, it's only half a revolution. Some students like to write theta cannot equal to 0 plus pi k, But if you picked k equals to 0, then you would get the same thing as theta cannot equal to pi k anyway, right? So it's just more efficient to write it this way. So this would be your answer. Now for secant theta. So secant theta is equal to 1 over cos theta. That means cos theta cannot equal to 0. And this is the exact same thing as letter A. So we're just going to copy paste it. So theta cannot equal to pi over 2 plus pi k k ei. And then for cosecant, this is 1 over sine theta. And sine theta cannot equal to 0. Theta cannot equal to pi k k ei. And it's the same logic as letter B. So here, this is where you start talking about some new stuff. So, given the equation secant theta is equal to tan theta over sine theta, determine the NPVs for the equation. So you're going to set this up into two different parts. So one called each term, and one called denominator. So for each term, you're going to address each individual term in your equation for both sides. And you're going to talk about the NPVs. So secant theta is the same thing as 1 over cos theta, right? And we know for cos theta, theta cannot be equal to, where is it? Pi over 2 plus pi k. And then for tan theta, it's sine over cos. Therefore, it's the same equation. And then for sine theta is just really sine over 1, so there's no NPVs in this one, so you just say none. Now, we're only going to focus on the denominator. So your denominator could not be equal to 0, because you can't divide anything by 0, right? So that means sine theta cannot be equal to 0. So even though on the left side there was no NPVs for sine specifically, now on the right side for your denominator, sine is going to have an NPV. So that's why you need to do both parts. So here, sine theta cannot equal to 0. That means theta cannot be equal to, where do you write it? Here. Theta cannot equal to pi k k ei. Oops. Now, to answer the question, you're just gonna write NPV, and you're just gonna write down a list of what theta cannot be equal to. So here, theta cannot equal to pi over 2 plus pi k k ei. And even though this equation applies to both secant theta and tan theta, you're only going to need to write it once. And now the other equation we have here is theta cannot equal to pi k k ei. And that would be your answer. So here, letter B. Numerically verify that theta equals 60 degrees and pi over 4 are solutions to the equation. So we're going to plug it into this equation still. So to do this, you're going to set up a t-chart. And on the exam, they're going to give you a blank t-chart as well. So I just want you to get used to this format. So here, you're just going to break it up. So secant theta on one side, so the left side of the equation, and then the right side of the equation. So tan theta divided by sine theta. And then you're just going to replace theta with 60 degrees, and then we're going to repeat the whole process again for pi over 4. So here, secant 60 degrees, and if we do our special triangle, 60, 30, that's an ugly 30, square root 3, 1, 2. Secant 60 is going to be 2 over 1, which is just 2. And then tan 60 over sine 60 is the same thing as square root 3 over 1 divided by square root 3 over 2, which is the same thing as square root 3 over 1 times 2 over square root 3's. The square root 3's cancel, and you're left with just 2. So here, we both get 2 as our final answer. That means the left-hand side equals right-hand side. And now, we're going to repeat the same process for pi over 4. So here, secant theta, tan theta over sine theta. So secant pi over 4, that's related to this special triangle. So here it's 1, 1, square root 2. So secant theta pi over 4 is the same thing as square root 2 over 1, which is just square root 2. And then tan pi over 4 over sine pi over 4 is the same thing as 1 over 1 divided by 1 over square root 2, which is the same thing as 1 over 1 times square root 2 over 1, which is just square root 2. So the left-hand side equals the right-hand side. And then you're done the equations. So here, we're going to do example 3. Given the expression sine theta over tan theta, determine the NPVs between and including 0 and 2 pi. So this is exactly like letter A, except now we have a specific domain, which means we are not using a general equation. So your domain here, between and including 2 pi, because it has the word including, that means you're going to add a little line under your Pac-Man. I wrote that wrong already, but it should be like this. So here it's the exact same setup, where we have each term and your denominator. So for each term, for sine theta, there is none. For tan theta is equal to sine theta over cos theta, which means cos theta cannot be equal to 0. So theta cannot be equal to pi over 2 and 3 pi over 2. And again, that just comes from the coordinates here, because cos is equal to 0 at pi over 2 and 3 pi over 2. And now, for your denominator, this one is a little trickier. Like, this is where a lot of students struggle to understand the rules for this one. And honestly, I can understand, because I have trouble honestly kind of explaining it. But I'll try my best, and if you have questions, I can try going over it in person again. So here, your denominator cannot be equal to 0, right? So that means tan theta cannot be equal to 0. So here, if you have tan theta is the same thing as sine theta over cos theta, right? And that cannot be equal to 0. If you had if you had cos theta equal to 0, so let's say your denominator was 0 now, that would make your function undefined. But we already addressed that over here. So that means we don't want sine theta equals to 0, because if your numerator was 0 and you divide your numerator, if you had 0 over any number, right, it's just gonna be 0. And I know it's a little confusing, but an easier way to honestly just remember this, and a little tip you should remember, is if your denominator is tan theta cannot equal to 0 wherever sine theta is equal to 0. So here, sine theta is equal to 0 at 0, pi, and 2 pi. So whenever you're in the denominator section, that means your numerator of your denominator cannot be equal to 0. I know it sounds confusing, but bear with me. But for this specific question, tan theta cannot equal to 0. That means sine theta cannot equal to 0. You can just remember that rule. And that's it for each individual part. Now for your NPVs, you're just going to make a whole list. So here, theta cannot equal to, it doesn't really matter the order. I usually just write left to right of whatever I see. So on the left side, pi over 2, 3 pi over 2, 0 pi, 2 pi. The order doesn't matter. This would be your answer. So here, simplify the expression. So this is related to the exact same question we wrote just now. So here, when you're simplifying, that means you're going to break it up into terms of sine and cos. So sine theta over tan theta is the same thing as sine theta over 1 divided by sine theta over cos theta. The reason why I wrote sine theta over 1 is because when you flip the fraction in your denominator later, due to fraction rules, it just makes it easier to see what's happening. But you don't have to include that 1, that's just my preference. So here, that's going to be the same thing as sine theta over 1 times cos theta over sine theta. And again, this whole thing comes from tan theta. So here, the sine thetas cancel, and that means you're going to be left with just cos theta. And that's going to be your answer. So here, given the expression cos theta is over 1 minus sine theta, state all NPVs between 0 and 2 pi. So, same setup, each term cos theta, there's none. For the number 1, there's none. And then for sine theta, there's none. Because here, all your denominators are just 1. Now, for your denominator cannot be equal to 0. Therefore, this whole bottom part here cannot equal to 0. So 1 minus sine theta cannot equal to 0. That means 1 cannot equal to sine theta, or the other way around, sine theta cannot equal to 1. That means theta cannot be equal to what number? So here we're given a domain 0 and 2 pi. So looking at our coordinates, where does sine theta equal to 1? That's going to be up here, because again, sine theta, or sine, is related to the y values of coordinates. So theta cannot equal to pi over 2. And that would be our answer, because there's no general solution since we're given a domain. And that's it for today's lesson.